that we need to engage with today. So I hope you guys still remember everything we learned so far under electrolysis, especially the first law of electrolysis. Do you all still remember? Hello, are you there? Please answer me. Do you guys still remember everything on electrolysis? Okay, so let's move to the second law. So the second law of electrolysis talks about the same quantity of electricity passing through the same two different electrolytes, and it states that the mass deposited should be directly proportional to the chemical equivalent to it. So what the law is trying to say for the Faraday second law, the Faraday second law of electrolysis. It states that when the same quantity of electricity, pass to different electrolytes, passes to different electrolytes. Anytime you see me underline a word, it simply means I'm abbreviating it. Is that okay? So when the same quantity of electricity passes through different electrolytes, the masses of the substance should be directly proportional to their chemical equivalent weight. The masses of substances are proportional to their chemical equivalent weights. So mathematically, what it simply means is that your mass is directly proportional to the weight. Now, there are so many times when we have more than one masses of a particular substances. So it simply means we can have our M1 in ratio to the second mass to be also directly proportional to the equivalent weight, which is equal to the first weight and the second weight. So this is the first formula for the Faraday second law of electrolysis. Just the mathematical representation of the definition of the Faraday second law of electrolysis. The M1 and the M2 means the masses of the substance that is deposited. The mass is deposited. While the E1, the E2 represent the equivalent weights, the chemical equivalent weights. Now, another thing you need to understand after this mathematical illustration of the Faraday second law of electrolysis is that the chemical equivalent weight has its own formula. Sometimes they don't give you the chemical equivalent weight. They can give another thing, and they expect you to use the parameters you are being given to find your chemical equivalent weight. There is a formula for chemical equivalent weight which says E equals A over V. This is another formula that you need to pay attention to in case they don't give you your chemical equivalent weight. So the A here represents the atomic mass of the element. So if they don't give you the atomic mass of the element, remember we have number of mole equals mass over molar mass. Are you getting this thing little by little? So in case they don't give you the atomic mass, then you use this formula again to calculate your mass. Is that taken? Why your V is the valency. The valency is the number of electrons that is gained or lost. Is that taken? The valency. So this is another formula that you need to pay attention to. We started from here. We said the mass is directly proportional to the chemical equivalent weight, which is M1 over M2 equals E1 over E2. So in case they don't give you your E, which is your chemical equivalent weight, use this formula to calculate your atomic mass, to calculate your chemical equivalent weight using the ratio of your atomic mass and the valence. And if they don't give you your atomic mass, you use the other formula we did under stoichiometry to calculate your atomic mass. That is very simple and straightforward. So equivalent weight is equal to atomic mass over valence. Now we have a general formula. There's another formula that we have, which is also used in electrolysis. It is M equals your Q over 96,500 multiplied by your M over, this M is capital letter, over V. This is the general formula for that we will be using in some specific questions in electrolysis. So M equals Q. This Q, remember we said Q equals IT in the last class, the columns. So you can use this formula to calculate your Q. Then you can use, you know the valency, you know the mass and all. Then you can get the required question. So I want us to, because I said that we'll be speeding a lot today, to quickly tackle one or two questions under that before we move into 5 basic electrolysis that will be asking, because it is included in your syllabus and it will be asking. You cannot actually run away from that question. It is a very important part. So I hope you understand all these formulas before we begin to apply them. Do you have anybody that does not understand this formula? It is very clear. Now, there's a question here. This question is very, very simple. Actually, they said the same quantity of electricity passes through silver nitrate and copper sulfate. And I said, find the ratio of the mass deposited. This one is a very straightforward question. Let me fix it here. Please, if I'm speeding too much, please let me know. I just want to cover a few things today. So look at this question. They said the same quantity of electricity passes through silver nitrate. The same quantity. So this is referring to the second law. Okay. They said passes through silver nitrate and copper. So they said find the ratio of masses deposited. Very simple. And they give us atomic mass. Sorry, I didn't copy the question. So they gave us atomic masses for silver to be 108, the valency to be 1, copper to be 63.5, the valency to be 2, and up. So if you want to calculate for silver quickly, we want to calculate for silver for Hg. So since our formula here says E equals A over V, which is atomic mass of the element, over the valency, isn't it? So since E equals A over V, therefore our A atomic mass is 108. our V valency is 1. So this is 108, right? For copper, E equals A over V also. Our atomic mass here is 63.5 and our valency is 2. 63.5 divided by 2 is what? 2 divided by 6 is 3. 1, 13. 2 divided by 13 is 6, main 1. That's 15. That's 7. That's 5. Sorry, maybe 1. That's 31.75, isn't it? Now, we've gotten the equivalent weight. The equivalent weight for silver is this, right? The equivalent weight for copper is this. Please, do we get it to this extent? Hello? Okay, thank you. So the question says we should find the ratio of the masses. It's so simple. So the ratio of the mass here will now be the mass of the first substance over the mass of the second substance. So that would be 108 ratio 31.75. And somebody help us with this. Calculator. Please, let's be very fast. 3.4. So that's 3.4 ratio 1. So in the question, like what I have here, you didn't, the question is not giving you, the options are not in this form. What they write in the option is that copper deposits 3.4 times more mass than silver. Silver deposits kinikon. So the answer simply means silver has deposited 3.4 times more mass than copper. Please, do you get it? Because silver has 3.5 times more than copper from this ratio that we got here. Please, is that taken? Please, are we all clear? Okay, so please, let's quickly move on to another thing. I want us to cover 2 solving topics today. Let me look for more. Okay, this one is also same thing. I believe you guys can do something like this. Everybody should quickly do this. You can see they are very simple questions. Let me quickly go to my school and get some other questions. So quickly do this and tell me the answer. Everybody, very fast. 1 minute, 2 minutes, you are done. Is someone talking over there?
So I not give us the valencies. Are we to calculate that?
So they gave you the data. Please, let's be fast. Okay, I think I see a complex example now. This is 2002. Are we done with that? This time we should be doing question and answer. Thank you, Titi. 12:1. Titi got 12. Any other person? Paul, 12:1. Lillian, what about you? Gift, what about you? 12:1. Thank you. That's That should be correct. 108. 27 divided by 3 is 9. 108 divided by 9 simply means that silver deposited 12 times more mass than aluminium because aluminium has the lesser value. Please, do you all get the interpretation? All right. So let's quickly move to another thing because of our time. There's a question here. I think it's a bonus question, but then some people can still miss it. I just want to be careful because it's a jam question also. They said, how much silver will be deposited when, let me just copy it. Please, can you guys do this? He said, how much is just a common sense question. He said, how much silver will be deposited when 6,500 coulombs of electricity passes through silver nitrate? So give us this reaction, Ag plus plus E minus. It simply means 1 mole of electrons is deposited to give 1 mole of silver, because that's a charge of 1, isn't it? The molar mass of Ag is 108. That one is constant. So what would be the mass of silver that will be deposited? Anybody? If 1 mole of electrons deposit 1 mole of silver, now how many mass of silver will be deposited by the molar mass of 108 of silver? Anybody? It's also 108. So 108 gram of silver will be deposited. Please, do we all get it? I just want to be sure we are together. So let's check another. I saw this question now. I think I like it. 2002. Please, if I'm getting too fast, please let me know. I just want us to be more faster today. So look at this question. They said a current of 5 amperes flows through copper sulfate for 40 minutes. Find the mass of copper deposited. They gave us the atomic mass of copper. They gave us the valency. They gave us Faraday. They want us to calculate the mass of copper to be deposited. So it simply means we are using the general formula for Faraday with what I'm seeing, which is equal to M for me. M equals to, please, is Suzanne in the call? I want to know the number of students on the call, so I can know how to call people. Suzanne is not in the call. Okay. Thank you. Please, if you are in the call and I have not mentioned your name, let me know. I know Gift is in the call, on the call. Titi, Paul, Lillian. Who has? Is any other person? Paul, please help me. Any other person on the call? Justice. Is Justice there? Okay. All right. So now looking at this, they want us to find the mass of copper deposited, right? Now, we have the valency, which is our V. We have the atomic mass, this guy, which is 63.5. The valency is 2. Now, the Q, the charge. Okay, they did not give us the charge. So this is what I'm saying the other time. This is what I was saying. Very fast. Oh, you don't speed though. Let's see if you are correct. You got 3.95. Let us write it down. 3.95 grams. So a current of 5 flows through copper sulfate for 40 minutes. So we can convert this to seconds. That would be 40, 10, 60. I'm teaching you today like a jam student, like you are going for jam. That's why I'm jumping step. And I want you to speed with me because you guys are going to the war front very soon. And I'll not be there with you. Now, we've gotten the time to be 2,400 seconds. We have the current to be this. So Q equals IT, isn't it? So our I is 5. That's 5 times 2,400. 5 times 2 10. So 5 times 4, 12. 20, 0, 2. 5 times 2, 10. That's 12. 0 is 0. Hope I'm not doing a mistake. That's 12,000 column, isn't it? Now let's slot in everything. 12,000 divided by 96 around 5.12 multiplied by 63.5 everything divided by 2. So you can do the calculation. I don't have. What's the answer? Anybody? Is Paul right? I think it is also got 3.95, right? Okay, that's good. So I think you guys are getting it already. So can you guys do this question? Please, are you all together? Lillian, Gift, please, anytime I'm getting too fast, let me know, like I said. And Lillian, are you there? Now she follow me go Dubai. Just manage this space. So this is the question. He said a current, sorry, I did not copy a current passes through silver nitrate and copper sulfate. They are both connected in series. If 2.16 gram of silver is deposited, calculate the mass of copper deposited. So they want us to calculate the mass of copper deposited. This is actually simple. It's similar to what we did before. Please, are we doing it already? What is the mass of copper deposited? Let's be fast. We've spent 30 minutes already. $6.36 gram for copper. We got 6.36 gram. Any other person? Gifts, are you there? Give to you. What's your answer? Titi, what's your answer? Lillian, what's your answer?
So I made a mistake.
What do you got?
I used 21.6
21.6.
instead of 2.16. I just saw it now.
Okay, so what should be your answer?
That's
Titi, Gift, Lillian, Justice. Is 0.35. That's Gifts. Any other person? I don't want us to waste time. Let's quickly calculate it. They said we should calculate. Where is the question? Said a current passing 0.635. That means you and Gifts, you guys are right. Okay, TC also got 0.2. That means I don't need to do it. Lillian, should I still do the correction or we should proceed? Do you also get the same thing? Very good. Justice, is Justice still there? Eh? Are you saying something? Okay, let's move on. I think all of you are clear. So let's move to this. I should work it out. Okay. Let me go back to the question again. So the question says a current passes through a GNO theory and copper sulfate. Say they are connected in series. So if 2.16 gram of silver is deposited, so the unit is the mass of silver, calculate the mass of copper. So they want to know the mass of copper deposited but we don't know the equivalent masses, the equivalent weights. They now gave us silver to be 108, the valence is to be 1, copper to be 63.5. So let us cram it 108, 63.5, 1, 2, 2.16 gram, because I won't be able to come back here again. 108, 63.5. That's 1, 2. Now, if you want to calculate the equivalent weight, now, the equivalent weight for silver, for Hg, to simply be 108, since it's valency of 1, that is 108. For copper, I think it's 63.52, right? So that would be 63.52. What will it give us? That's 3, 1. Now, let us quickly apply the law. The law of Faraday says that if, how will I put it now? That the mass is directly proportional to the equivalent weight, right? So now we have two substances. That would be the mass of silver, the mass of copper equals the equivalent weight E1 over E2, isn't it? So the mass of silver, what's I've forgotten, 2.16 is the mass deposited. That is 2.16 gram over the mass of copper is what we are looking for. Let's call it X. What's the equivalent for silver is 108, right? For copper, that's 31.75. You make X the rate of the formula. So that would be 108X equals 2.16 multiplied by 31.75 divided, no, not divided, sorry. So that would be X equals 2.16 times 21.75 divided by 108. So that will give you your X. Is that how? Somebody help me with the calculation so that I can be sure you'll get the same thing. What was the value for Hex?
I'm getting 0.715.
What do you say?
0.715.
0.715. You mean I don't get to help me calculate this stuff here. You got 0.634.
Yes.
Yeah, I think that's the answer. You used what I give you here, right? Okay, so let's quickly move to formula. Let's move to another topic. That's electrolysis of formula. I missed. So I want to check the next topic. I think it should be electrolysis of some substances. Sorry. Okay. I think I've gotten what I'm looking for. So let's move to electrolysis of some common electrolytes. It is a very important topic. That's the next thing under your electrolysis. Let's move to another. Electrolysis of common electrolytes. So they can ask you one or two questions from these aspects. How am I even writing? Sorry, I'm speeding too much. So hope you still remember when we talked about what happens at the cathode, what happens at the anode. No, we said at the cathode, there's always reduction, that is gain of electron, because we'll be applying these things here. And we said at the anode, there's always oxidation, which is loss of electron. So it simply means cations will go to the cathode and anions will go to the anode, isn't it? Another thing that I want you to understand under this electrolysis of electrolytes is that anytime you hear a solution, that means water is involved. And one of the ions that will be discharged is hydrogen ion and hydroxy ion, irrespective of other ions in that uh, electrolysis of that electrolyte, except if you are using probably inert electrodes, probably platinum or carbon electrodes, that they are unreactive and all. But anytime you have an aqueous solution, hydrogen ion and hydroxy ion is part of the ions that will be discharged. But that does not mean they will be the only one that will be discharged. There's something we call reactivity series. Let me try and get a diagram for the reactivity series. I think I have that. Okay, let me drag it. Let me copy it. So look at this reactivity series here. So there are cases when you will have more than one. I want you to study this guy. There are cases when you will have more than one anion, or you have more than one cation. So the question will be that which one will be discharged? Which one will you be giving preference to? So once you understand this electrochemical series, you can see that the most reactive, they are the easily oxidized ion. Why the less reactive? They are the one that have strong tendency to gain electron. Can you see it in the diagram? So we'll be applying these things as we proceed. Hope that is taken. So let's start with the electrolysis of dilute sulfuric acid, which is H2SO4. Please, have you screenshotted this? Can I proceed? All right. So let's start with the first. Like, you cannot escape questions under this thing. The first one we are checking now is electrolysis of dilute sulfuric acid. That's H2SO4. So the first thing you need to do is to identify all ions that are present in that solution. That's the first thing. I will be writing this out for the first time. For the next ones, I won't be writing the procedures. Identify all ions that is present in the solution. Now, if you look at it, now, dilute sulfuric acid is in water. Yes or yes? Yes, it is in water. So both the acid and the water, they are contributing to the ions. So sulfuric acid has its own ion. Water has its own ion. So from sulfuric acid, what are the ions that we can possibly get from sulfuric acid? From H2SO4, we can get H plus, isn't it? What other thing can we get? We can get SO42 minus, isn't it? Please, are we together, everybody? Okay. From water, what can we get? What do you say, Chano? From sulfuric acid, we can only get H plus and SO42 minus. If sulfuric acid dissociates, what will it give us? That's what the question is talking about. So this is from sulfuric acid. Now from water, I can't see it very well. You said we get HO minus. From water, we will get, anytime water dissociates, it will only give us hydrogen ion and hydroxy ion, H plus and OH minus. So I want to attend to something. Sorry for that. So H plus and OH minus, isn't it? So it simply means the ions present in the solution. Please, I'm trying to take my time to explain this. After this, the next electrolysis of electrolytes, I won't be doing this explanation. So it simply means the ions present in this solution. The ions present in the solution are what? We have H plus. We have H plus is twice, isn't it? So you write it out one time. We have SO42 minus. What are the third thing? We have OH minus. Please, if they ask you to write out the ions present in the solution, these are the three things you are writing. Please, do you get it? Please, are we clear to that extent? Now, let us now look at what will be discharged. Let us start with the cathode. What happened at the cathode? Is it now reduction? Cathode reaction. That is reduction, Abi. Okay. So when we say something is reducing, what does it mean? It wants to gain electron. So part of these guys, which one is positively charged? You know, I told you the one that is positively charged simply means is the one that has the higher tendency to gain electron. Why the negative charge is one that has the higher tendency to lose electron? Please remember that concept. Because in the real sense, the positive charge simply means is at loss already. So it needs to gain. You know, when you see H plus simply means -1. If you see Na plus simply means -1. You know, Na is 2,8,1. It simply means it has lost 1 electron. That is why we say Na plus. So the one that is positively charged has the higher tendency to be reduced. Please, do you get that logic? So now looking at these three ions here. We have H plus, we have SO42 minus, we have OH minus. It simply means hydrogen is the one going to be reduced, isn't it? That is H plus getting reduced, E minus to what? To hydrogen. Hydrogen is a diatomic gas. That would be H2. So this is not balanced. We had 2 to this. So we have 2 plus. So that means we had 2 to this. That means we have 2H plus 2E minus to give H2. Now, if they ask you to give the reaction at the cathode reaction state, what are you writing? This alone. Do you get it? So it simply means hydrogen ions has gained electrons and they combine to form hydrogen gas. They can ask you, how many electrons does hydrogen ion gains? They can ask you, what does hydrogen ion, when it is discharged, what does it form? It's combined to form what? Hydrogen gas. Please, do you get how question can come out in this first electrolysis? Thank you. And another thing is that anytime you see hydrogen gas being discharged at the cathode or being discharged at any electrode, but every time it's always at the cathode, because hydrogen gas cannot be discharged at the anode. So anytime you see hydrogen gas being discharged, bubbles will always appear at the cathode. So in case they ask you that, what inferences can you give to an observation of bubbles being happen at the cathode? That means it's hydrogen gas that is being discharged. Is that taken? So that is another thing. That is a wire question. It's not actually a jam question. So let's quickly go to anode. Gift, do you get what happened at the cathode already? I think Gift said she's having an issue with this topic. Gift, are you with us? Hope I'm not too fast, Gift. So let's quickly go to anode. So anode, the first thing you should remember at anode is oxidation. Now, this is the issue. We have 2 ions that can be oxidized. We also have OH minus and also negatively charged. But mind you, sulfate ions, SO42 minus, they are not discharged easily. It simply means SO42 minus cannot be discharged at the anode, especially at a place when we have another anion, which is OH minus. Let's say, for example, the only anion that we have is SO42 minus. We can proceed to just put it at the anode and say, okay, this is the only one that can discharge. But sulfate ions, they cannot be discharged easily. As if at a place when you have other anions like OH minus. So the reacting ions is OH minus at the anode, not OH minus. I hope that is clear. So hydroxide ion will now lose electron because at the oxidation is loss of electron, OHL, or you call oxidation is gain of oxygen. I think I gave you all these things before. Gain of oxygen or loss of hydrogen. And check the previous notes to get it. So that means OH minus will be oxidized to lose electron to form water. So it will form oxygen plus water. So plus E minus. For heavy of your anode oxidation, you know it is actually losing electron. So that means the corresponding electron will be at the product side. Is that taken? Now we need to balance this. We have 2 oxygen here. We have 3 oxygen here. We have 2 hydrogen here. So how do we balance this? Can anybody help us? That's 2, 1. We have to make this even. If we put 2 here, that will give us 4 hydrogen, right? This will give us 2 oxygen. 2 oxygen, that is 4. That means we can put 4 here. And that means we can put 4 also here. So it simply means these hydroxide ions has lost its electron and oxygen gas has been formed at the anode. Is that taken? Please, do you get the electrolysis of dilute sulfuric acid? Gifts, is it getting? Lillian, do you get it? Paul, Titi. All right. So let's quickly move to another thing. So there are some people that they can cram all these electrolysis because they know that question will always come out. So please and please, if you need to cram, go and cram it. Know what happens at the cathode. Know what happens at the anode. They can ask you what gas is formed at the cathode. The one we just did now, at the cathode, that was hydrogen gas. At the anode, that is oxygen gas. Is that taken? So, and they can ask you, you know, if hydrogen gas and oxygen gas is formed at the respective electrodes, the electrode discharge, it simply means the electrolysis of dilute acid, of sulfuric acid essentially, is essentially the electrolysis of water, because hydrogen gas is formed at the cathode and oxygen gas is formed at the anode. Do you get that concept? In case they ask you in the question, every electrolysis of a dilute acid will always give you electrolysis of water. Do you get it? All right. Now let's quickly move to electrolysis of let's pick another color. Electrolysis of aqueous copper sulfate. That's the B. Electrolysis of aqueous. I hope you understand when they say something is in aqueous state. Aqueous copper sulfate. Now, in this type of cases, please pay attention to the electrode they give you. If they don't give any electrode, very simple. You just do it straightforward. But if they say by using, let's say, inert electrode for this guy, please, if it is inert electrode, it has different discharge at the electrode level than from if they did not give you inert electrode as the electrode being used. You know, inert electrodes, they are unreactive electrodes like graphite, like platinum and all. So let's quickly check the ions present if we use inert electrode for copper sulfate. Since it's an aqueous state, so we have hydrogen plus, we have OH minus. For copper sulfate, CuSO4, we have Cu2 plus, isn't it? We have SO42 minus. So we have 2, isn't it? Are we together? So let us go to the cathode reaction. Cathode reaction. At the cathode reaction, what should we have at the cathode reaction? We should have either copper plus or H plus. Now, that will take us back to the chemical reactivity series. And that is why I said you should go and pay attention. Please, after the class, for those that are not very good at in the reactivity series, please go and learn it properly after the class, please. So instead of hydrogen ion to be discharged here at the cathode, should I go back to the, you can see copper. Instead of, said it is least reactive and it has strong tendency to gain electron. So instead of hydrogen to be discharged, sorry, Cu2 plus will be discharged to give copper. So we need to add ion to it, E minus. So since it's 2 plus, that would be 2E minus, right? So this one is balanced. Copper is not diatomic. So that means 2 electrons is being released at the cathode. So two electrons is being gained. Sorry, we are at the cathode. 2 electrons is being gained at the cathode, and solid copper will be deposited on the cathode. However, that is taken. At the anode side, can somebody tell me what will happen? We have OH minus, we have SO42 minus. Which one will be deposited at the anode? Lillian. Lillian.
OH.
OH minus. Very
Yeah.
good. So how will you balance it? I think it's the same thing with the one we did the other time. So that would be, that would be OH minus O2 plus H2O plus E minus. So 2 to make it even. That's 4 for hydrogen, 4 for oxygen, so 4 for electron. So sometimes they can ask you to collapse the cathode, but that one is actually, you will do it in your 100 level when you go to university. But for JAMB, I've never seen a question like that. In case they ask you to collapse, it is simple. You just add what happens at the cathode to what happens at the anode, and you balance the electron. So simple. But if they have to, don't say, do I even know this at all? Let's quickly go to the next one. So in case they ask you what is produced or what is deposited at the anode, copper is deposited at the cathode. So we have copper metal. At the anode, what is deposited? Oxygen gas is deposited at the copper. So let's say, for example, we use copper electrode here, because this one, please pay attention. Like I said, if you need to cram these things, please go and cram it. Let's say we don't use inert electrode, we use copper electrodes here. So if we use copper electrode, the electrodes themselves will react because we are using copper as the electrode itself. So at the cathode, copper will react. At the anode, copper also. At the cathode, copper will be deposited on the cathode. And at the anode also, copper also, we lose out electron. We give out electron also. And they will dissolve to form copper ion. So let's quickly do it now. Let's start with the cathode. So the cathode, what happened at the cathode? Gain of electron, so that would be copper 2 plus because it is gaining. So this will be 2 minus to give us copper solid. So from +2 to 0, it simply means this one has -2 before, and it has become a 0. So it has gained electron to become a 0. It's now stable, isn't it? So this is what happened at the cathode. And at the anode, instead of copper 2 plus, copper solid will dissociate, it will ionize. So copper atoms will now lose electron to form copper 2 plus. So this will be +2 E minus. So here, copper is being deposited on the cathode. Here, copper is deposited. Simply means copper is formed in the cathode. Please don't mind my writing. I'm trying to manage space. So this one, copper ion is formed. Simply means copper dissolves. So they can just ask you some tricky questions. They can ask you that in the electrolysis of copper sulfate, using copper as the electrodes, what is dissolved at the anode? And they will put in this guy here, all this ion here. They will put O2 gas. You know, we have O2 gas deposited at the anode using inert electrode, isn't it? And we have copper using inert electrodes at the cathode electrode, isn't it? Now, here it has changed to copper. What is dissolving at the anode is copper. and copper ion is the one that is being formed. And here, copper is the one deposited. Copper is deposited here. Now, if they now ask you a question, you will see this O2 in your question, in your option. You will see OH minus. You will see copper in your answer. You will see hydrogen. Please, do you get how it can be confusing? So please do well to pay attention to that. Please, do we all get that before we move into the third? Oh, are you still there? Titi, how are you? So we spend an hour. Oh my God. Okay. Sorry, guys. Your exam is far. In the next class, like what we said in biology, in the next class, we just quickly go through every topic that remains, like scan. We just scan through. And oh, this is what you will do for me in the next class in chemistry. Go and give us like you can message me so that we can talk. Like 2 or 3 year past question on chemistry that you want us to treat in the next class. So after we're going through the remaining topics, we will do all those questions from A to Z. Also biology. Who should I even recommend? Maybe Titi should also do that. Give us some questions, a year, particular year or 2 years that we can do together in biology in the next class. So we just scan through the remaining topic, then we will treat JAM questions together to be able to apply everything we've been taught. So that is when I will understand, oh, you do not understand this place very well. Because it is one thing for you to know, it's for another thing for you to be able to apply what you know. Some of you will know it, and when you see it, you'll be like, and because of fear, you will even forgotten everything that you know. Please don't allow fear. So the third thing is electrolysis of dilute sodium chloride. Anytime I'm going to the exam, I always go with this confidence. I smile. I'm not trying to be proud, but then I just know that I cannot fail. So let's that also sink into your brain. You cannot fail. You cannot fail. No matter the mass failure, you cannot fail. Electrolysis of dilute sodium chloride. It is possible we use about 3 hours in the next class so that we can cover a lot. So now, dilute. I believe all of you can do these things now. Let's look at the ions present. I don't think we should have issue with ions present now. They said diluted, so that means water. That means we have hydrogen plus, we have OH minus, isn't it? What else? So NaCl, we have Na plus, we have Cl minus. Isn't it simple? It is very simple, right? Are we together? Okay. So now let's quickly move to the cathode reaction. I think this is brine, and this actually always gives students some issue also. Now, at the cathode reaction, what will be deposited? This is the confusing part. You know, people will be expecting that, so you see sodium, is it hydrogen? And the funny thing is that none of these two is being deposited. Now, the reason why it is not nitrogen and not sodium is because sodium is very reactive. So you cannot see sodium. If, how will I put it? If sodium is being discharged, as it's discharging, it's reacting again, like Oduro. So as sodium is discharging, is reacting, so you cannot go with sodium. And hydrogen, the hydrogen ion in this state, they are very few because water is not ionizing NaCl very much in the electrolysis of diluted NaCl. So there is more sodium, sodium ion than hydrogen ion normally. But sodium ion is highly reactive. That means we cannot use sodium ion because of its reactivity level. We cannot use hydrogen ion because it is very minute, it's very few. Because water does not ionize much. So what we simply do is that instead of now you using hydrogen or using Na plus, you will simply use water molecules. So water molecules itself will be reduced at the cathode reaction, at the cathode electrode. It will be reduced to form hydrogen gas back. So hydrogen gas will now be formed. But that hydrogen gas is coming from water. Again, that is being reduced by itself. I don't know if you get that simple explanation.
We're not
So
seeing your screen, no.
it is from your side though. I can see my screen. Lillian, can you see my screen? So it is from your side. So that means water itself will be reduced. So that means plus E minus to be reduced to form what? If water is reduced, it will form hydrogen ion, hydrogen and an hydroxyl. So how do we balance this? We have 2 hydrogen here. We have 3 hydrogens here. We need to make this one even. So we have 2 here. We have 4. 2 oxygen. Okay, so we put 2 here. So we have 2 electron here. So it will gain 2 electron. Gibbs, can you see my screen now? Okay, so you can see hydrogen gas is formed here. In case they ask you, sincerely speaking, if they don't ask you the previous one that we did under copper sulfate, they will ask you. And if they want to ask under copper sulfate, it's like they ask you using copper electrode. So they will ask you which one is discharged or which one is formed at the anode, because they know many people will go for oxygen. Or they can ask you this electrolysis of brine solution, dilute NaCl, and they can ask you what is formed or deposited at the cathode. It is hydrogen gas, because it is water itself that is being reduced. Or they ask you what is being reduced. They will put this hydrogen plus, they will put this Na plus, they will put another plus. They can now put water. So many people will either pick Na plus or H plus, whereas the answer is water. Please, do you get it? So at the anode, can somebody help us? What will be the form at the anode between Cl minus and OH? OH minus will be discharged instead of chloride, isn't it? At the anode. So if OH minus is discharged, so that would be OH minus, the same thing that we get the other time. That's O2 plus water plus E minus. So that would be even 4. So this would be 4. So it simply means oxygen gas is formed. So all these things, please be writing it out. So it simply means hydrogen gas and oxygen gas is formed in the electrolysis of dilute NaCl. Which one do we do the other time, that hydrogen gas and oxygen gas? Is it not electrolysis of dilute H2SO4? Oxygen gas, hydrogen gas. Do you see? So actually, I will make my research. It looks like every electrolysis of dilute acid will always give us will always give us hydrogen gas and oxygen gas. And heavy electrolysis of dilute base will always give us oxygen gas. And I want you to make your findings there. Please, do you get what I'm seeing now? Does anybody get that? Or you are lost? Or you got it, Abby. Titi, you are lost. I'm trying to give you one of you, Joe, that I've not confirmed. So I want you guys to confirm it and get back to me on the group. Every time I ask you to get back on me on the group, you will not get back to me. I don't know. I said I'm looking at it like every electrolysis of dilute acid will always give us at the cathode, it will always give us hydrogen gas and oxygen gas at the anode. That means it will always form water. So every electrolysis of dilute acid is also equivalent to the electrolysis of water. Do you get that chemistry term? Do you understand that one, Titi? So it simply means, without you disturbing your brain, if they give you the electrolysis of dilute hydrochloric acid, without you stressing yourself, the answer is hydrogen gas and oxygen gas. Do you get the logic? Maybe you go for a competition now, without you stressing yourself. They finish saying the answer and question like this, just tell them hydrogen gas is formed at the cathode, oxygen gas is formed at the anode. They'll be like, wow, because it is a logic. Now, I'm trying to say that it's looking like the same thing for dilute base also, but I will make my findings after the class that every electrolysis of dilute base will always give us the same thing. It will give us hydrogen gas at the cathode and oxygen gas at the anode. Please, do you get it now? So let's quickly move on. You should know that at the anode, the dilute solution favors which one? It favors oxygen. It favors oxygen formation instead of chlorine formation, in case they ask you. So let's quickly go to electrolysis of concentrated NaCl. This one is dilute NaCl. Okay, this concentrated NaCl is what we call the brine solution. So dilute is not brine. It is concentrated. Electrolysis. Please, do you get what I just explained now? Lillian. Paul, you don't get it. Which aspects? Paul, is it this third part that you don't get, or what I'm trying to form?
This one you just finished saying now. The
Electrolysis of
brine-
dilute NaCl.
Yes.
Okay. Do you agree with the agents present, the H plus, Na plus, OH minus, and Cl minus?
No, I mean you said that one is no brine, something like that.
Okay, I was talking about brine solution. I was saying electrolysis of concentrated NaCl is what we refer to as brine.
Okay, sir, I understand.
Do you understand me now?
Yes, sir.
I was calling dilute. I was saying brine the other time, so I was trying to correct that. So the ions present here our time has gone now. You guys have to read and cover up for the many topics. So. Suzanne is not in the class now. Suzanne, where are you? And later you come. Don't worry. So we have H plus, OH minus. We have Na plus, Cl minus. So now the little difference, let's go to another slide. Now we have H plus, comma, Na plus. They are the possible ions that can be discharged at the cathode, isn't it? And we have Cl minus and OH minus as the positive possible ions that can be discharged at the anode. Now let's solve this cathode first. This cathode still remain the same for both the concentrated sodium chloride and the dilute sodium chloride. So the cathode reaction still remain what we wrote there. That is, water will be discharged, not Na plus and H plus. And I believe you know the reason right now. So to give H plus plus 2E minus, liberating water plus hydroxyl sorry, hydrogen gas plus hydroxyhelium. So we make this even. So that means we have 2 oxygen and 4 hydrogen. So this will give us 2E minus. So that means hydrogen gas, just as usual, is being formed, isn't it, at the cathode. Now let's move to the anode. You know, the other time for the diluted sodium chloride, the discharge of the ions favored which one? It favored the OH minus in order to form oxygen gas at the anode, isn't it? At this time, remember we are dealing with concentrated NaCl. So it simply means this guy here, this base here, is highly concentrated. So therefore, the discharge will be favoring the chloride ion because they are very concentrated, and they will be discharged at the anode at the expense of the hydroxy ion, OH minus. Is that taken? So instead of OH minus to be discharged at the anode, what will be discharged at the anode is Cl minus, the chloride ion. Please, is that taken? Are we there, everybody? Please, can you guys hear me? Have I lost my network? Okay. So do we get it? You know, at the dilute NaCl, please don't let it be confusion. Which one will be discharged, Lillian? Is it not OH minus?
In dilute is OH, but in
Uh-huh.
concentrated chloride.
So
Sorry.
chloride will be discharged to form chlorine gas. Chlorine gas is a bleaching agent. You can use it for many, all these IPO, all this. If you are going into the industry, you'll be able to apply some things. So let's just continue with electrolysis. Don't let us digress. So Cl minus, we give chlorine is diatomic, right? Plus E minus. Now we have that would be 2 Cl minus. So 2 minus will give us 2 E minus here. So it simply means chlorine gas is formed. So basically, the electrolysis of concentrated NaCl is used to form chlorine gas. So in the laboratory, when you see professor doing electrolysis of NaCl, they need chlorine. They want to use it for something, maybe for an analysis. So chlorine gas is being formed in the electrolysis of concentrated NaCl. This is that taken. It simply means at the cathode, hydrogen gas is formed, and at the cathode, chlorine gas is formed. Is that taken? So when you go to the industry, I don't know if anybody is going to the industry, you will see that there are some polyvinyl chloride. I don't know if you heard about polyvinyl PVC, all these disinfectants, all of them. You cannot do it. The major component there is chlorine. It simply means in that industry, anytime you are working there as a staff, you'll be doing electrolysis of concentrated sodium chloride a lot there, so that you can have a lot of chlorine that you can use to manufacture every disinfectant. And you can go and buy chlorine gas, but it is very expensive to be able to preserve. So if you have a good industry or a big industry, you can be producing it yourself, then use it for the purpose that you want to use it for. Don't let me teach you so that you not steal it and use it to have money, and then you not give me money. Let's go to the last part, electrolysis of the molten NaCl. I know Gift is a very sharp guy. So you'll be doing as if you did not hear anything. And Titi, electrolysis of is that they call it fused or molten. Maybe we should stop at these are the 5 things that JAMB will. Is that you say 1 or 2 questions, but you cannot avoid it. If they don't ask you question, we are lucky. or let me say you are unlucky because you know it's already, so you are unlucky. You can't see my screen. Ah, it is from your side, though. See, it is from your... Lillian, can you see my screen? Yeah, it is from my side. So now they said, okay, thank you. They said fused NaCl. So it simply means water is not present. Did you get the difference now between the aqueous, the concentrated, and the fused NaCl? They can ask it out of the theory. They can ask for sulfuric acid also. They can ask for copper sulfate using inert electrode or copper electrode. They can ask for sulfuric acid. Straightforward. That one is dilute. If it is dilute hydrogen gas and oxygen gas. Chicken. If it is dilute sodium chloride, hydrogen gas and oxygen gas is formed. Chicken. If it is copper electrodes that they use for copper sulfate, it is copper. So for the cathode, copper is being reduced. For the anode, copper is being oxidized, isn't it? So they are very simple. For concentrated NaCl, hydrogen gas will still be formed, but chlorine gas will be formed instead of oxygen gas at the anode. Now we are talking about the 51. This is very simple now. The electrolysis of fused sodium chloride. So here, since water is not present, it simply means the ions present will be what? So we'll not be having H plus and OH minus again. So we'll only be having Na plus and Cl minus. Is that again? Now, if we have Na plus and Cl minus, so let's go to the cathode reaction. All of you that you are running to the medical field, please go to industrial field also. We need you. There's money in the industry. Many of you after your medical clinic, they'll be giving 150K, 200K. Medical doctor, 200K. What do you want to use that one to do in Nigeria? This well. Don't let me discourage gifts. I think gifts is don't let me talk. Which money? The money for medical practitioners are consistent now. You'll be at least don't be thinking options. So no, I am live now. Everybody's listening to me. So please don't say it is this uncle that convinced me. I'm just asking you to pay attention to number one. Know your. I don't want to use the word calling. Know your strength. What are the key things you know? What do you know how to do most? Is it calculation? Don't let anybody. Don't be too focused on medicine, nursing, pharmacy. They are very, very good topic. The reason why they are good is that once you are done with your undergraduate, you will see work. If you don't have a good connection, maybe you don't know people very well, you will still see work. Like 80% of the time or 70% of the time, you see work, irrespective of who you know, you will see work as a doctor, as a nurse, as a pharmacist. But you will not see some high-paying work if you don't have some connection. Like you not see a job of 400K, 500K as a medical doctor if you don't have a good connection. They get it. That's just the only thing. But you'll be earning 200K. So if you want to buy a car, let's say you want to buy a Lexus of about 13 million naira, so that means you have to save for how many years? So 200K in 1 year is how much? 200K times 12, that's 2.4. 2.4 in 13 million places. The mathematician in our midst, that should be around 10. That means you will save for 10 years before you buy a Lexus car. And that is only if you are not touching the money. So do you get the logic? So just everything's not about money. Go for your passion, eh? It is where. So the cathode reaction, what will be discharged? That's Na plus, isn't it? Plus E minus to give Na But also you can become an academic person, you can become an academician, you can become a lecturer, you can become a professor. Your passion is money. My own passion too is money. So you can become a professor. So with that, over time, your pay as a junior lecturer, they will be paying you 250,000, 300,000. So after like 5, 6 years, as you began to do more thesis, you began to make more research, you do your masters, they've been increasing the money. I think in federal institution is every 4 years or so. I can't remember. Before you know it, after about 15 years, you become a professor, or about that 10 years or 12, something like that, sha. And your pay will increase to maybe 600,000. But the last time the Minister of Education they were talking, they said I think the highest paying professor in Nigeria from the federal government or the state government is not collecting more than 1 million naira. That's the highest paying professor in a month. They get it. Apart from the private university, that was why they said the federal government should increase their salary then, that it's too low. Like the highest paying professor that has spent about 30, 25 years is not any more than 1 million per month. And if you're in the industry, you can make 10 million in a month. Let's leave that. Where are we? Cathode reaction. What will be formed here? Sodium metal, in case they ask you, isn't it? So at the anode, what will be formed at the anode? Titi, hope you are getting it. Gift, hope you are very clear now. Cl minus, right? Gift, are you there? See how to. So they will be 2. So chlorine gas is forming. Gift, are you there? Paul, is Gift still there? She did not want to talk. Leave her. She will later eat cake. She used to do lunch today. So I think we are done. I think we are done with the electrolytes. Yeah. Let me quickly give you some notes. In case they ask you, I don't think they can ask you, but in case they ask you, I'll be dictating.
You called me just now.
What do you say?
You just called my name. You said gift I there.
I called your name.
Don't worry. I don't even know what I'm hearing.
How will you hear? When I'm asking you, are you there? Are you there? You did not answer. When it can hit you, you will know.
Sorry, I went to the hospital just now. I went to go and bring my grandma's results. So I was not paying attention.
You that you are saying you are struggling with electrolysis, you went to greet your mama, your grandma during class. You and your grandma, you are going to the exam hall together. You will see. You put your grandma to your left, you will sit down. You and grandma will be doing exam. Why can't you go after the class? Factors affecting discharge of ions. Quickly write. Factors affecting discharge of ions. In case they ask you. Number 1, the positions in the electrochemical reactivity series. Positions of ions in the electrochemical or reactivity series. When to bring our medical results. Why can't you wait till 2:30?
Electrical.
Electrochemical or reactivity series. The position of ions. The first diagram I gave to you. Number 2, concentration of ions. What time is she traveling today? Is it before your class? Is it not after your class? Well, shall I have something to say? Say I'm not. Number 1, position in electrochemical series. Number 2, concentration of ions. Number 3, the nature of electrode. In case they ask you, all of these are factors that affect the discharge of ions. They can write Roman figure 1. they can write the valency of ion. The valency of ion. Figure 2. Position in electrochemical series. Figure 3. They can ask concentration of ion. Figure 4. They can write nature of electrode. And figure A, they will say 1 and 2, 1, 2, 3, 4 are correct. B, 1 and 2 only. C, 2, 3, 4. D, only 2. So the answer is 2, 3, 4. The fourth one is presence of competing ions. Presence of competing ions. Presence of competing ions. Have you written the 4? Position of electrochemical, the pressure of ions in electrochemical of the activity series. 2, concentration of ions. 3, nature of electrode. 4, presence of competing ions. Another subtopic, use of electrolysis. Uses of electrolysis. Number 1, extraction of metals. Can use electrolysis to extract metals. Can extract metals like sodium. Can use to get sodium like aluminium and all. Extraction of metals. Can also be used to electroplate, to plate some metals for electroplating. Number 3, purification of copper. Under that copper sulfate, when we are using copper electrodes, one of the advantage, anytime you go into the industry, maybe doing your IT, your internship, you do your IT in your 111, if you are doing a 5-year course, do your IT for those that will be going to the industry. You will see them using copper electrodes for the electrolysis of copper sulfate. So they want to purify copper. That method is basically used to purify copper. So purification of copper, this can also be used to manufacture many chemicals. The manufacture of chemicals, like I was talking about chlorine the other time, chlorine gas, which is a very essential chemical for bleaching and some other disinfectants that you use in your toilet, and also to wash also, and also for anodizing aluminum. Let me just stop there because of our time. We have less than 20 minutes to go. Electrochemical cells. Electrochemical cells convert chemical energy to electrical energy. Okay, these people give you the redox series here. Let me paste it for you. Electrochemical cells convert chemical energy to electrical energy. So this is the redox series, the methods that are above here are more reactive. That is the first methods, just like the diagram, in case you want to put that down. All these ones are very simple. I'm seeing corrosion, rusting of iron. Let me just quickly explain this as we round up electrolysis. They said corrosion is the electrochemical deterioration of metals. So anytime there is oxidation of metals, like this, oxygen and water are involved or are being added to metal, there will be rusting. And that's one of the purpose of electrolysis. We used to electroplate some metals for electroplating. Is that taken? So rusting requires oxygen in case they ask, and it requires water. Those are the two things rusting requires. And how to prevent corrosion? We can use painting. That is, the air, the water, they will not come in contact with the metal. So once you paint it, even if water is being added, the paint has this oily phase. The surface tension will not permit water to stay or air to penetrate into the metal. We can also use greasing. It's a lubrication method to prevent corrosion also. So what greasing does is that it will block the moisture from entering into the metal. You can also use galvanization. Galvanization is zinc coating. It's specifically used for zinc. So we use to coat the zinc surface so that air and water will not enter. We also have cathodic protection. Cathodic protection is a sacrificial method of preventing corrosion of a metal. What do we do? You will use a less reactive metal. You sacrifice it for a high reactive metal. You get the logic? It's as if God just came to the world to die for us. He came to sacrifice himself so that we can live. For example, now, Gift like me so much. Gift can say, Mr. Mindset, send me your account number. I have 50K in my account. I want to give everything to you. And she will be going hungry throughout the week. Me, I will be eating shawarma. I'll be taking yogurt. I'll be flexing. And she should just be in one corner. She'll just be praying for me. God bless you, sir. God bless. So that is sacrificing. So some metals can sacrifice for another metal. That is what we call cathodic protection. So you will break down one metal to sacrifice for the other metal. And the last one is electroplating. Electroplating is when you try to protect the metal layer. And that is electroplating. So with that, we come to the end of electrolysis. The next topic we should check is energy changes. Oh my God. We have a lot of things to cover. The endothermic reaction, the exothermic reaction, all this all these points. How should we do it now? You guys have to read it. How many of you have read the topic? I've watched the video. You watch the chemical changes. Do you understand it? So that we can move to another thing. It is very simple now. Everybody understand that. So we should not do it now. Should we just check question and answer under it? Okay, let's quickly check question and answer under. Let's look for more jam question under electrolysis. So that let me delete this one. I think I have more questions on there. That's great. It is not easy because I joined jam. That's yes. When I was like you too, I did my jam. It striked. I still did another jam. The last jam I did was 2015. We strike for more than 1 year, almost 2 years in Lautech then. I have to go and do another jam at OAU. I want to study medicine. Then it is medicine. I have to become a medical doctor. Like when Gift see me, say, Dr. Moses. All those things, they have prestige, but as you go up, you know that it's not about prestige. I will still become a doctor as a researcher. So you still call me Dr. Moses, but I will not become a medical doctor. So that my children, once they will not be calling me Mr. They say doctor. My dad is a doctor. The children will be happy to, they'll be proud of me. My dad is a doctor. My mom is a doctor. So when we go for PTA meeting, can we welcome Dr. Moses to the pulpit, to the stage, which I will not stand up. I will not do younger. Dr. Moses. All those things, you don't put money to the table. Okay. Can be a doctor and be poor. Yeah. Before you buy your car, you spend like almost 2 years. Some people even go and borrow money to buy a car. All right. Now. I've seen a question here, but it's simple. I don't want to ask this one. These questions are very simple. This question, we did it. This JAM 2013 question at my school. Look at this question. They said, during the electrolysis of disulfuric acid, the gas liberated at the cathode is A, oxygen, B, chlorine, C, hydrogen, D, sulfur dioxide. In fact, it's a stupid question. Why will you put chlorine inside the option? I hope everybody knows the answer. I hope you all know the answer. Okay. Which product is obtained at the anode during electrolysis of concentrated sodium chloride solution? JAM 2014.
Glowing gas.
Chlorine gas. Very good. Clap for yourself. Look at this 2016. Okay. This one is also simple. So like I said, so Paul, please help us with a lot of past questions in the next class so that we can do them together. The factor that does not affect the product of electrolysis is A, nature of the electrode, B, concentration of the electrolyte, C, the temperature of the solution, D, position of ions in the electrochemical series.
Temperature.
It's a very long question, actually. During the electrolysis of aqueous copper sulfate using copper electrode, wow, the electrode dash. During the electrolysis of aqueous copper sulfate using copper electrodes, the anode dash. A, gain mass, B, loses mass, C, gives off oxygen, D, gives off hydrogen. Are you guys there? Are you guys there? Answer me now. Why you not answering? It should not take more than 5 seconds, though.
So I
Do
can't
you
call
know
the option again.
what is happening? Do you know Ellen Paul, this comedian, this lady? They're doing the electrolysis of aqueous copper sulfate using copper electrode. That is the electrode they are using. Said something happened at the anode. What happened? Then the anode dash. A, gains mass. B, loses mass. C, gives off oxygen. D, gives off hydrogen. Gives off oxygen. Another contradicting option. Any other contradicting option? Gifty, where are you? Titi, where are you? Lillian. Let me even look at the number of students in the class since morning. Six people. Wow, Benita. I didn't call you since morning. Nikki, good. Hey, you guys are here. I didn't talk. Ah, you guys are secret agents. Let me give you a course. Go and study. What's this course? Oh, oh, that was the course I wanted to study before. Oh God, what's the name again? Is a sub course in a course under. Is a detective. All these they can detect the DNA. It's under all these people that some women they will give the father to the young child. What's the name of this course? Daniel, what's the name of this course? Under biochemistry. Forensic. Yeah, thank you. Go on, Nikki, good. Are you with me? I'm Benita. Go and study forensic biochemist. You will like it. Sometimes you just need a blood sample. You go and work on the blood sample in the lab. Sometimes the thief or the accuser can come forget an handkerchief. Just take the handkerchief. Go and use. There's some machine that can use it to detect the fingerprint. Or you can travel out because this Nigeria, you may not see work on time. As we not finish forensic and you now be doing now you become a teacher. You'll be teaching biology and chemistry. Lillian, B losses mass. Thank you. Where are you? So you are booting for the past how many minutes? Do you want to take mic? Oh, Lillian,
Sir?
where have you been? What took you? What took you that long?
So I just wanted to be sure. I was thinking.
You're thinking, please, that minute is too much.
No, I'm
So
not sure it
that
was
is
5
it.
minutes.
What do you say?
I'm not sure it was 5 minutes.
It's just a very tricky question, but it's very simple. It should not
Yeah.
take more than 5 seconds. During the electrolysis of aqueous copper sulfate using copper electrodes, the anode does what? What happens at the anode? You can say, the copper, it was solid before. It dissociated, it's discharged, and it becomes copper ion. So that means the copper has lost its mass. That means at the anode, the copper is losing mass. Do you get the logic? At the cathode, the copper gains mass because from copper 2+, it becomes copper solid. Benita, do you get it? Nikki, go, do you get it? It's so simple. So that's it. So sometimes they just ask you some questions and it will just pay attention. Don't rush yourself too much. Don't understand the curiosity of the examiner. So we can take more past questions after the class. So an exothermic reaction is one in which do you want more question? Give because because of the time we have less than 8 minutes to go, 10 minutes. What's an exothermic reaction? That one is simple now. You should not.
One that
This
gives
one, I don't think they can answer this one and this question.
is
Exothermic
one that
reaction.
gives
Yeah,
up heat now.
it is released. What do you say? Who is talking there?
Me.
Who is me? Only God is I am that I am. Tell me your name.
Lillian.
If you say me and keep saying me, how would I know me and me? Okay now. So, which of the following points is endothermic? A. Combustion of methane. B. A neutralization reaction. C. Dissolving ammonium chloride in water. D. Respiration. They should not put this data. Gives that combustion reaction. Do you know what endothermic reaction is? What is combustion reaction? Gifts. What is endothermic reaction? And what is combustion of methane? Oh, I'm hungry. Hello? Gifts, come and pay my lunch money today now. I pick it for God's sake. Gifts, are you there? He said combustion. What's the answer? Lillian. Oh, what's the answer? Anybody? Gift, you miss it. They won't we do these chemical changes like this?
So I ain't call the options again.
Combustion of methane, neutralization reaction, dissolving ammonium chloride in water, respiration.
A combustion of methane.
All of you, we have to do it again. All of you, after the class, go and watch the video. Please and please go and watch the video on chemical changes. After watching it, type down inside the group. And if you like, do big girl, do big boy, don't type down.
So is it C?
You see now, dissolving ammonium chloride in water, it will give it. It will, as we are dissolving, that's why sometimes if you put detergent, do it when if you are washing your clothes today.
Yes.
Put detergent and add a little water to it and put it in your palm and squeeze it together. You will feel this kind of heat. Especially if you are in the cold. If there is cold, you like it. Okay, this is sweet. So that is an example of endothermic reaction. Endothermic reaction simply means heat is being absorbed from the surrounding, while exothermic simply means heat is being released to the surrounding. So combustion of methane, you are releasing heat now. The enthalpy change for an exothermic reaction is what? This is a 2012 question. The enthalpy change for an exothermic reaction is what? A 0, B positive, C negative, D constant.
Negative.
Negative because it is released. Yeah. So simple. This one is simple. Which of the following changes is accompanied by an increase in entropy? Do you know what entropy is? The measure of the disorderliness and orderliness of a commodity. So now, if the answer which of the following changes is accompanied by an increase in entropy? A. Freezing of water. B. Condensation of steam. C. Dissolving salt in water. D. Formation of ice. All of you, you've not read the chemical changes. So, I would not even enter calculation question. Nobody.
So repeat your question, the options again.
Freezing of water, condensation of steam, dissolving salt in water, formation of ice. So which one increases disorder? All of you are Olodo. Let's go.
Oh, jeez.
All of you are Olodo. Go and read your energy changes. So
A.
in an energy profile diagram for an exothermic reaction, I give you a video, I define entropy for you. I still tell you that which one increase disorder. You still don't know the answer. In an energy profile diagram for an exothermic reaction, the energy of the product is what? In an energy profile diagram for an exothermic reaction, the energy of the product is what? A, higher than reactant. B, equal to the reactant. C, lower than the reactant. D, independent of the reactant.
Lower than
Lower
the
than the reactants. Lower than the reactants.
Me, say it clearly. And if you want to collect money from mommy, you will be say it. Let me hear you. You are now
Lower from the reactant.
lower from than the reactant. OJB. Which quantity represents the minimum energy that is required for a reaction to occur? A, enthalpy. B, entropy. C, activation energy. D, free energy. If anyone does not know this,
activation energy.
disappear.
Activation energy.
You should tell me the answer immediately now.
Activation energy.
Ah, gift. Is it still there? Uh, you should tell me the answer. Sincerely, I'm expecting everybody to echo the answer. Ah,
It's activation energy.
I didn't hear the question.
there is Wala. Which quantity represents the minimum energy required for a reaction to occur? Minimum energy.
So activation energy.
What is the answer? You are giving me thumb up. What is the answer?
Activation energy.
John, nah.
Gifts. It is where. Lillian, what is the answer? Ah, so you don't know the definition for activation energy. The minimum energy that is needed to start a reaction.
Energy.
Ah. It is well now. If you guys are going for jam next week, about week, the Lord be with you. Okay, we've done this before. They said entropy is a measure of what? A reaction is spontaneous when the value of delta G is dash. A positive, B 0, C negative, D maximum. 2018.
So come again.
A reaction is spontaneous when the value of delta G is what? Is it positive? Is it 0? Is it negative? Is it maximum?
I think it's negative.
My sister.
I think it's negative.
So it's negative.
Nobody can answer that.
Negative.
Hey, Jesus.
It's negative.
Chineke. Lillian,
So wait, sir, come
I'm
again.
not
Come
proud
again.
of you again. I
Sir,
disown
come
you as
again.
my daughter. Gifts. I'm not proud of you. I'm never proud of you again. Paul, I disown you as my son.
Sir, come again now, please.
A reaction is spontaneous when the value of delta G is what?
Negative.
Ah,
So maximum.
go and check it yourself. It's 0. Less than 0. And it's 0.
Inside less than 0 is negative.
0 call. When it's negative, that is less than 0. That one indicates spontaneity, like it will be spontaneous. Is zero. See a mouth like is zero. Hope that is taken. The last question. Which of the following reaction is always spontaneous? A, delta H positive, delta S negative. B, delta H negative, delta S positive. C, delta H positive, delta S positive. D, delta H negative, delta S negative. You are the one that said we should not do chemical changes now. Now you are sweating, not that fun.
Sir, come and give me the question. Sir,
Nobody to answer that too.
sir, can you repeat the question?
Which of the following reaction is always spontaneous? We talked about delta G. Spontaneous for delta G means it must be negative. So we want to talk about delta H and delta S for the enthalpy. Now, then I said, which of the following reaction is always spontaneous? Delta H positive, delta S negative, delta H negative, delta S positive, delta H positive, delta S positive, delta H negative, delta S negative. Gifts. Gifts. You fold my hand. Don't come to my DM again. No. Don't check up on me. Check up on yourself. Check up on yourself. I'm no more part of you again. Okay, so that will be the end for today's class. My system went off. I never knew I was not charging again. So